Hello. I figured I'd do a tutorial. I'm just gonna do a tutorial about table reference because I see nobody doing tutorials about them. And whoops, need a Mac core cell. And from what I can tell, well, I have to explain something first. I have to explain how audio travels. So basically, this is how audio travels in digital audio. Not just in Reaktor, but Reaktor makes it easier to see this. But it's easily editable in Reaktor. Basically, what audio does is see all this white. This obviously means that this is an audio signal. But I shouldn't have done that. That's feedback. But so what happens is that the audio comes in, and then basically digitally it samples all the amplitudes to a fixed rate, and then it gets quantized to this rate right here, 44,100 hertz. So every second 44,100 samples of amplitude are coming in. So to my best assumption of what this does is it stores all of those amplitudes that are getting sampled. So that's a good way to display this is if you get a table framework map. Make a sample. Get a sample. Make something to trigger the sample. And then I'm going to make an audio output. So what I'm going to do is I'm basically going to recreate all of the amplitudes that are getting stored in here, just so you have an idea of what this table framework is, because when you go to the info, it doesn't say anything about it, and the manual is very brief in explaining it, and it's super annoying that it doesn't explain much. But alright, so what I'm going to do is I made a quick bus for that array, because that's what this is. This is the manual says it's a 2D array. I don't know what that means. I just know that it stores amplitudes. That's all that I'm aware of it doing right now. So I'm going to get a size module that'll tell me how big it is. I'm assuming this is what this is going to do is that when the sample plays or is triggered, it's going to tell me how many amplitudes were in that sample. That's what it sounds like to me. So then I'm connecting it to a size module, and then I'm gonna get an index, and then I'm gonna index the samples in the array, but I'm gonna get a round, multiply module. You'll see what I'm doing in a second. You'll understand why I'm doing this, hopefully. So I'm gonna connect this to the size. So what this is gonna do right here is I'm gonna have this, whatever the event coming in here is gonna go from 0 to 1, and that's gonna select basically what's different indexes throughout the total size of the array. And because just by doing this you get decimals, I decided to round it to the nearest whole number because there's no decimals in this array. And then after that, I'm going to do a read module. I'm going to want to here connect this to this too, because this is the clock. And it's going to output. And sure. Actually, I want to make this an audio, because I'm going to use a ramp oscillator. So then I'm going to get a ramp. And this is not bipolar, this is unipolar, meaning it goes from 0 to 1. So if you have that, it shows a line in between here as if it has negative values, but it doesn't, which is kind of deceiving. Here, let me pull up an oscilloscope so I can demonstrate that a bit. So basically, these are below this line is negative values, above this line is positive values. What a ramp osc does, it only has positive values, and it's basically a saw wave that only has positive values. That's it. So now that I got that hooked up, the reason I'm doing that is so basically I can play through all the samples that the play through all the amplitudes that are getting stored in this array at once, so I can recreate it out of the table reference. And this is really simple to do. I'm just doing it to show everyone what the heck it does. I'm just getting a tempo info so I can get this spitting out the sample at a constant rate. Make it quarter notes, I guess. I don't know. Oh, and what this table info thing does is basically I don't even read that. See, at a rate of 120 BPM, there's it basically, okay, it displays how many seconds are in each bar of whatever BPM you're going to. So whatever a whole note would be, it displays how long a whole note would be, how many seconds it would take for that whole note to play. So at 120 BPM, a whole note would be 2 seconds long. It's not saying that right now, but I know that. So for quarter notes, if I divide it by 4, then it'd be 0.5 seconds for each quarter note. So that's what I'm doing there. Kind of quantizing it a bit, I guess. I don't know. So hopefully when I press this button, it should recreate this sample. And it's kind of slow. Maybe I can speed it up. I'm gonna actually just try to control. Speed that. Now it's going it's the whole note now. It's gonna speed it a little slower. Actually, I'm gonna put this from 1 to let's get decimals. Ooh, it's really fast. So basically just replaying the sample really fast. And it's going to keep looping because it's an oscillator that it's going to keep repeating until something stops it. But yeah, I just basically recreated the sample. It might sound a little different because it's playing at a different speed than maybe the original sample is, but it's close. And I hope you could have heard me over that clapping. And I'm guessing you couldn't. Well, here's the original sample. It's pretty close. All right. Well, that's all.